Hello students, today I'm going to teach you illustrating rational algebraic expressions. After going through this video lesson, you are expected to define rational algebraic expressions, identify rational algebraic expressions, evaluate rational algebraic expressions, and relate rational algebraic expressions in real-life situation. First, let's define rational algebraic expressions. A rational algebraic expression is an expression that can be written in the form P over Q, where P and Q are polynomials and Q must not be equal to 0. Here are examples of rational algebraic expressions. If you're going to take a look at the examples, all are in the form of fraction. This is now an example of not rational algebraic expression. If you're going to take a look at these, they are also in the form of fraction, but they have a square root and the exponent are negative. Here's a useful checklist in identifying whether the expression is a rational algebraic expression. First, the expression must be in fraction form. Next, the expression must have in its numerator and denominator a constant, a variable, or a combination of both that are polynomial expressions. The expression must not have a negative exponent, a radical sign, or a fraction exponent in the variable or variables in both numerator and denominator. Take note, the denominator of rational algebraic expression or the RAE must not be equal to 0 because division of 0 means undefined or meaningless. Here are the steps in determining the excluded values. We have here a study tip. Just pay attention to the denominator of the expression to determine the excluded values. But what is excluded values? Excluded values are the values that will make the expression undefined. Now let's have the steps. Step 1, let the expression in the denominator be equal to 0. Step 2, solve the equation to determine the value or values of the variable. Let's have an example number 1. Identify the value of x that will make 6 over x minus 3 undefined. First is we're going to get the denominator, which is x minus 3. And then we're going to equal it into 0. After that, we're going now to solve for x. Using the addition property of equality, since this is negative 3, we're going to add positive 3 in both sides. And then we're going to solve. Negative 3 and positive 3 will be cancelled. X is equal to 0 plus 3 is equal to 3. This is now the excluded value for the expression 6 over x minus 3. When we substitute x equals 3 in this equation or in this denominator, this will become undefined. Next, example 2. Identify the value or values of n that will make 18n plus 1 over n squared plus n minus 2 undefined. Same procedure. We're going to get the denominator, which is n squared plus n minus 2. And then, since this is a trinomial, we're going first to factor it. Since this is a general trinomial, we're going to think of two numbers that when multiplied is negative 2 and when added is positive 1. And that is positive 2 and negative 1. Now that we already have the factors, we're now going to equal each factor into 0. This will become n plus 2 equals 0, and this one, n minus 1 equals 0. Again, using the addition property of equality, n plus 2, we're going to add here negative 2, and also in the other side, negative 2. And then we're going to solve. 2 minus 2 is 0, n is equal to 0 minus 2 is negative 2. Now, on the other side, we have n minus 1 equals 0, n minus 1, this is minus 1 or negative 1, we're going to add positive 1 on both sides. Negative 1 and positive 1 will become 0. N is equal to 0 plus 1 equals 1. We have now two values or two excluded values, and that is negative 2 and 1. When we substitute negative 2 or 1 in the denominator n squared plus n minus 2, this expression will become undefined. Now, after having or knowing the excluded values, now let's proceed to evaluating the expression. Example 1. Evaluate the expression y squared minus 1 over y cubed minus 3 when y equals 2. To evaluate this expression, we just simply substitute the value of y into the y. Let's rewrite y squared minus 1 and y cubed minus 3. Substitute the value of y, which is 2, in y. This will become 2 squared minus 1 over 2 cubed minus 3. And then we're going to simplify. 2 squared, that is 4 minus 1 over 2 cubed, which means 2 times 2 times 2 is 8 minus 3. And then solve. 4 minus 1 is 3, and 8 minus 3 equals 5. This is now the answer, which means when we substitute the value of 2 into y of this expression, the answer will become 3 over 5. Let's have another example. Evaluate the expression 5x squared plus 6x minus 11 over 1 when x equals 2. Since the denominator is 1, just copy the numerator, which is 5x squared plus 6x minus 11. And then substitute the value of x, which is 2. We're going to write 5. X is 2. Then copy squared plus 6. Substitute x with 2 minus 11. Then solve. 5, 2 squared, that is 4, plus 6 times 2, 12 minus 11. 5 times 4, 20, plus 12 minus 11. 20 plus 12 minus 11, the answer is 21. And this is the value of 5x squared plus 6x minus 11 when x equals 2. Now, let's apply rational algebraic expression in real-life situation. Example, Vanessa can finish writing a module in X hours, while his brother Ryan can finish writing the same module in Y hours. Write an expression that will illustrate their rate of work to finish writing the module. To illustrate this, we can use a table. We have two persons involved in this problem, and that is Vanessa our brother Ryan. We are talking here about the time in hours. Since we don't know the time, Vanessa can finish a module that is represented by X. We're going to write here X, while Ryan, Y. And then to get the rational algebraic expression, we're going to make part of work over hours. Since the part of work is only a module, that means 1, and the hours, which is unknown, we're going to put X for Vanessa. While for Ryan, we're going to write it 1 over Y. And that is the rate of work to finish writing the module for Vanessa and Ryan. Example 2. The area of a rectangle is x squared minus 121 square units, while its width measures x plus 11 units. Illustrate a rational algebraic expression in finding the length of the rectangle. So we're looking for the length of the rectangle, which is, we're talking about the area. So the formula for the rectangle is length equals area of rectangle over width. Then simply substitute the given. For the area of a rectangle, we have x squared minus 121 over the width, which is x plus 11. And that is the rational algebraic expression in finding the length of the rectangle. And that's all. Thank you for watching. I hope you learn new things today. Thank you and goodbye.